Hello, my Algebra 2 students. This is Unit 6, Day 7, which is going to be focused on intercepts of quadratic functions. So we have been factoring away, and now we're going to be putting it to good use here. You are completely on your own for these notes, meaning that you're going to watch this, and instead of a post-video question, you're going to go right on to doing the homework, all right? So watch it, then homework. Now you know. All right. So what we are looking at, quadratic functions, we know anything, x squared. Finding intercepts, I mean finding the x-intercept, finding the y-intercept. All right. And we've done this earlier in the year. So to find a y-intercept, we set x equal to 0. To find an x-intercept, and keep in mind it might be multiple for x's, we set y equal to 0. So for our first example here, if we give ourselves y equals x squared minus 2x minus 3, right? If we're going to talk about the y-intercept, then we would simply plug in 0 here, 0 here, and then all you're left with is that -3. So you just want to remind yourself that it's a coordinate point. So that would be the point 0, -3, where it crossed the y-axis. For the x-intercept, oops, meant to put the little colon there. Here is where, and what we would do in this case is we would be setting 0 on the other side. And so x squared minus 2x minus 3, and then equals 0. So you can do this a couple of ways. You can do it by doing it on the graphing calculator. We can do it by factoring by hand. So to solve this, I'm going to show you two ways. So on the calculator, what we would actually do is we would go into y1 and set this equal. So into your calculator, whatever you got in y1, you can clear that out. And we can type in our x squared minus 2x and then minus 3. If we go to Zoom 6, you should get a pretty decent screen right here. And there we go. All right. So graphically, when we're talking about x-intercepts and y-intercepts, we're talking about literally where they hit the x and y-axis. So we already determined that the y-intercept was down here at -3. So it should make sense when you're kind of looking at my graph there, right? And then also where it's going to hit the x-axis. Now these ones are nice and pretty, so you can probably see on my graph that it's crossing back here at -1 and at +1, 2, 3. And so between those 3 points, you get a decent look at what this parabola looks like. It's not perfect because we don't know the vertex at this point, but that's not what we're focused on at the moment. All right, so you can get a decent sketch right here. All right, so the x-intercepts based on this, I'm going to do them in a little curly bracket. I can list them as -1 and then 3, or I can list it as -1, 0, that point, and then the point 3, 0. Now it came out really pretty. If it's not as pretty and you can't just look at it and tell, as a little reminder on the calculator, the steps would be to do second and then trace, and then you'd be choosing the 0. So let me run you through it one time. I'll zoom in a little bit on my calculator so you can see closer up. So we'd go second and then hit the trace button or second calc and then 0 right here. And so it's going to ask you for a left bound, right bound, take a guess. So if I'm trying to find that x-intercept right there, I would slide to the left of it, hit enter, slide to the right of it, hit enter. And now those two arrows on the calculator are pointing at each other, saying it's in between there. Then you get as close as you can, hit enter. Right? And what you can see is it came out perfectly at -1, 0. And then if you repeat the process to find the second intercept, second trace 0 again, you would slide on over. This time, to stay to the left, I would have to stay below a little bit. And then to go to the right, I'd have to slide up to the right and then take my guess in between. If you don't know your left from your right, now is the time to figure it out. Just throwing that out there. All right. Otherwise, there's your x-intercepts right there. All right. Now, some of you are probably like, we could have done this algebraically. And of course you could have. We just finished doing a ton of factoring. So on the calculator would be one way to do it. The second way to do it all right, would be to solve algebraically. And all that means is set it equal to 0 and then solve, all right? So if we factor this side of it, well, this one is just a nice little add, multiply, nothing crazy. So x and x, 3 and 1 will get us to 3, minus 3 and plus 1 to get us to that -2. And then when we split it and solve, I know we tend to get a little lazy and skip that step sometimes, but technically you're setting the factor equal to 0. And then we add, we can see those two x values come out. So as a reminder, either you're writing it as like a little set, maybe in those curly brackets for the x-intercepts, or it's probably a better habit just to get yourself to write it as a coordinate point so that you remember that that's exactly what they are. They are points on the graph. So we've got our y-intercept, which was at 0, -3, and our x-intercepts at -1, 0, and at 3, 0. So for these next ones, can you use your calculator? Of course. Am I going to force you to try to do it algebraically? Yes, you probably could have guessed that. So for example number 2, I want you to determine, again, all the intercepts. All right, so let me give you y equals 4x squared minus 1. And of course, if you're feeling really confident, you could pause, do it all, and then just check against what I come up with. Otherwise, we can say, okay, y-intercept, if we plug in a 0 here, that's just going to kick out -1. So the y-intercept should be at 0, -1. All right, and then the x-intercept, I'll make that part B. We're going to set this equal to 0. So here's where all our factoring skills come in handy. This is difference of perfect squares. And so we can make this 2x plus 1, 2x minus 1. I'm going to get a little bit lazy here. If I set it equal and move it over, this would give me -1/2. This guy would give me +1/2 right there. Right? And so that means my intercepts would happen at -1/2, 0, and then at +1/2, 0. Right? So it doesn't tell the full story, but you at least know this is where it's hitting the y-axis, here's where it's crossing the x-axis, and you can kind of put together a picture even without your calculator. Let's see if we can sneak in one more example here. So example 3, same thing, determine all the intercepts. If I go y equals 3x squared plus 13x minus 10. All right. You probably already figured out y-intercept is always easier because it's the x and stuff that's getting squared. So as soon as those pretty much get wiped out, this part's pretty easy. So this is the point 0, -10. That's where it's going to cross the y-axis. All right, where it's going to cross the x-axis. Well, when in doubt, if you find yourself getting stuck, you could always plug it into the calculator, because I didn't say you had to do this one algebraically. But this would be a good little reminder as to how to do a little slip slide divide or whatever the heck we called it, because of the fact that there is no GCF. And so you're stuck with that leading term. So if we multiply it over, let's see, this will give us x squared plus 13x minus 30. And then we factor. All right, x and x, this will be 10 and 3. Oh, I take it back. 10 plus 3 would give me 13, but positive times positive will not give me that negative. Ooh, got to be careful there. That's why I have my little whiteout next to me in case I jump the gun on something like that. Instead, I think we're going to go 15 times 2. If we go positive 15 and then -2, that'll get it done for us here. Okay. Don't forget, divide by 3. So when we divide by 3 here, divide by 3 here, we get x plus 5. And then we get 3x minus 2. And so then finally, when we go to solve, I'm going to squeeze it in here. I get -5. This one we would add 2 and then divide by 3. And so when we add 2 and divide by 3, that would give us positive 2/3. All right. If I mental math check here, let's see, 3x squared, outsides would give me -2, insides would give me +15, which will give me that 13 I want. Last would give me -10, and -10. Oh yeah, -10. That's this guy up here. Sorry. All right. And so my two solutions here is that the x-intercepts would be at -5, 0, and then positive 2/3, 0. Now, of course, if you did on the calculator, positive 2/3 is going to look like 0.6 repeating. So you just want to make sure you remember those little details. All right, we got one last one to look at, and then you guys are going to go and try the homework on your own. So last one, example 4 here. Ooh, I can get my papers to move. There we go. So same directions, find the intercepts. I'll just rewrite that in case you lost it from the page before. And I'm going to give you y equals 3x squared minus 18x plus 27. All right. So some of you might already be like, I don't even need to fully show the work. But if I go for the y-intercept, you can start to see how when you plug in a 0, that'll knock out. When you plug in a 0, that knocks out. You're always left with that last term. So the y-intercept is going to cross at 27 on the y-axis, or the point 0.27. All right, part B of it. Throw a 0 in here. Let your factoring skills shine through. All right, well, this one, it does have a leading term, but it's a GCF. So if you can take that 3 out, do it. It will get lost otherwise, kind of in the midst of a slip and slide, which isn't the worst when you're solving, but it's not great when you're just factoring. So still just always want to look for that GCF. So x squared minus 6x and then plus 9. And then this factors nicely into x minus 3 times x minus 3. Right? So in this case, when you get the same answer twice, you didn't do anything wrong. But what that actually means, this is called a double root. This 3 in front, you would set it equal to 0. It wouldn't do anything. It's going to affect the stretch of the parabola, if you can think back to our transformations unit. But it's not going to affect the actual intercept itself. But if I sketch this guy, what you would see is that over at positive 3, if the graph hits there twice, it means it doesn't pass through the axis, and your parabola would look something like this, where it's just tangent to the x-axis. All right, so let's do a couple of the homework questions from day 7 together. So just to clarify, questions 1 and 2, don't overthink it. They are already factored for you. You're just solving. That's it. All right. We did a bunch like numbers 3 and 4 in the notes. So I wanted to slide down and do one like number 8 together. So if you find that you have quadratic expressions or just any expressions on both sides, make sure step 1 is to get everything on one side so that you get it equal to 0. All right. I would always try to keep the x squared term positive. I think that makes things easier. So I'm going to move everything to the left side by subtracting, or in the case of the 4, adding it on over. So that's going to give me 4x squared minus 25x and then plus 6 equals 0. From here, there is no GCF to factor out. So if you want, you can use slip and slide. This would also be an option to do like some guessing and checking. So you have some options here. All right. Otherwise, I'm going to stick with the slip, slide, divide, whatever the heck we had called it in class. So multiply that 4 on over. From here, we're going to add multiply. So this should be 24 times 1, both being negative. To add up to that negative, give me a positive here. And then make sure, whoops, see, this is why slip slide divide is dangerous. You got to make sure to finish the process. Divide by 4. All right. So this one would become 4x minus 1. This one will just become x minus 6. Quick double check. There's 4x squared minus 24 minus 1. And then minus 6. That matches everything right here. And so x will become a positive 1/4. X would become positive 6. And the directions just say solve each of the following 4x. So you can leave it there. If you like the curly brackets, you could always put it in the curly brackets. Otherwise, just box it in. Doesn't matter. All right. There's 2 other ones I wanted to look at with you, just to make sure that you were okay doing these on your own. That's number 10 and number 12. So on number 10, it says consider the equation, determine the value of x algebraically. Very similar to the one we just did. So I'm going to let you do part A on your own. Part B, when it says use your graphing calculator to check the solutions for part A using the calc intersect. Using calc intersect, you'd have to go y1 and then y2. And of course, when you type those in there, we then have to make sure that we find a window that works. So if if zoom 6 doesn't work, we'll have to mess with it a little bit. So if we go 4x and then minus 5, and then 2x squared minus 5x and then minus 10. So I'm going to try my zoom 6 to see if that'll do it. So there's the linear function. And there's our parabola. So pretty close. We can see one intersection. If I can't see the other one, I might want to just change my window. I want to look a little higher. So I'm going to change the y maximum maybe to 15 and see if that's enough to do it. So there's my linear function again. There's my parabola, and it's just about hitting at the top. So we can kind of sketch this over here to kind of show that, all right, my parabola looks a little something like this. My linear function, which if you think about it, 4x minus 5 would cross down here at negative 5 and then have a fairly steep slope. So it's crossing up here. All right, to find those 2 intersections graphically, this is where it says use calc intersect. So we go to second and then trace, or second calc, and then trace 5 is intersect. Oops, I'm a little bit in the glare there. Sorry about that. So when we get close, it's going to say first curve, second curve, take a guess. So my intersection here is negative 0.5, negative 7. And then we repeat that. So second trace, intersect, slide it way on up there. And I come out with 515. Okay, so now something to keep in mind. We skipped part A. So when you do part A, what's going to match is not the y value, but what should match are the x values here. So you're going to want to make sure that your x values are coming out as negative 0.5 or negative 1/2, and then positive 5 here. All right. Okay, last one. Number 12. So number 12 says, given a quadratic in the form of x squared plus bx plus c. So they're clarifying into 1x squared. We just have to figure out the b and the c. Use the graph to determine the x-intercepts of the parabola. And then based on that, can we write out an equation? Okay, well, not too crazy. If we look at the x-intercepts, it crosses back here at negative 2 and at 1, 2, 3, 4. So my x-intercepts are negative 2 and positive 4. When it says use that to write the quadratic function, you have to think about when you go to solve, the step before this was, subtracting a 2 over and adding a 4 over. Let's go the other direction. Let's bring this back. So this, we would have to add 2 over. It would become x plus 2 equals 0. Here, we would have to subtract 4 over. It would become x minus 4 equals 0. And then the step before that, it would have been in factored form. So it would have been here as x plus 2 and then times x minus 4 equals 0. And now if you go one further, you would have to multiply this out by either foiling or box method to figure out what it looks like as an x squared problem. So the last piece of it is it's going to be y equals, and then whatever you get from multiplying that out. All right, that should be enough that hopefully the rest are pretty easy for you. We can always make time in class to take questions. Thanks, guys.